Right now, your body is under siege. Trillions of microscopic organisms crawl across your skin and airways, constantly probing for a weakness in your defenses. If your internal defenses were to pause for even a few hours, these microbes would immediately begin consuming your tissues, breaking down your very cells to fuel their own replication. The first line of defense is physical, your skin. But a simple scratch or wooden splinter shatters that barrier. Instantly, bacteria pour through the opening, dropping directly into a warm, nutrient-rich tissue layer. The invasion has begun. Almost immediately, the first responders arrive, macrophages. These massive white blood cells act as biological vacuum cleaners. They stretch out, engulf the invading bacteria whole, and trap them inside internal compartments flooded with deadly acid. This brute force infantry is critical for keeping you alive in the first few minutes of an attack. But bacteria divide exponentially, doubling their numbers every 20 minutes. Against that kind of math, a pure numbers game is a losing battle. The macrophages are going to be overrun. Realizing they are outnumbered, the macrophages release chemical distress signals. This triggers inflammation. Your blood vessels physically expand, creating wide open highways to rush fluid and fresh cells directly to the battlefield. If local reinforcements fail, distress signals reach the brain, intentionally raising your core temperature. Most pathogens thrive exactly at 98.6 degrees. By pushing to 101, your body literally cooks the invaders, while heat activating your white blood cells. Even with the heat cranked up and millions of infantry cells rushing to the site, some pathogens are simply too aggressive. The bacteria continue to slip past the defenses, pushing deeper into your tissue. The front line begins to collapse. Biological brute force and extreme temperatures have failed. To survive this invasion, your body can no longer rely on general-purpose troops. It has to call in a highly coordinated, specialized intelligence network. Enter the dendritic cell. This is the immune system's intelligence officer. When it encounters a pathogen, it doesn't try to eat the entire swarm. It rips the invader apart, extracts specific molecular fragments called antigens, and pins these pieces to its own outer shell. Covered in enemy intelligence, the dendritic cell does something highly unusual. It abandons the active battlefield. It slips into the lymphatic system, a parallel highway of vessels running throughout your entire body. It is heading for a lymph node. These nodes act as heavily fortified military bases. Inside, billions of specialized T cells and B cells sit completely dormant, waiting for orders. The dendritic cell moves through the sleeping army, presenting its captured antigen to cell after cell. It is searching for a precise physical match, the one single T cell or B cell out of billions that happens to have the exact corresponding receptor to defeat this specific invader. This microscopic trial and error process takes time. Days might pass while the battle rages on. Finding this precise physical match is the ultimate bottleneck. Finding it means recovery. Failing to find it means the host will succumb to the disease. Here we see the moment of connection. The antigen clicks into place on a specialized receptor. The dormant cell wakes up, and a process called clonal selection begins. This single, perfectly matched cell rapidly clones itself, creating a massive, specialized army designed to hunt one specific target. This new army divides its labor. Helper T cells act as field commanders, broadcasting chemical signals that direct the entire immune response. Meanwhile, killer T cells deploy directly to the tissue. If a virus has hidden inside your own cells to replicate, the killer T cells will assassinate those compromised host cells to sever the enemy's supply line. At the same time, the B cells execute their primary function. They act as biological weapons factories, mass-producing millions of tiny Y-shaped proteins called antibodies. These antibodies flood the bloodstream, traveling at top speed back toward the infection. Antibodies operate exactly like biological guided missiles. When they reach the battlefield, they latch directly onto the invaders. This physically paralyzes the bacteria, stopping them from moving or feeding, while simultaneously painting a massive target on their backs for the macrophages to easily clean up. Under the weight of this highly targeted, overwhelming counterattack, the infection collapses. The specialized forces execute the remaining pathogens with a lethal precision that the general-purpose infantry could never have achieved on their own. With the battle won, the immune system doesn't immediately stand down. Inside the lymph nodes, temporary microscopic structures called germinal centers form. These are intense military boot camps for the surviving cells. Inside these boot camps, a select group of B cells are converted into memory B cells. Through rigorous chemical testing, they are trained to recognize the exact invader they just fought, as well as new pathogens that mutate slightly. Their recognition profile actually becomes broader. These memory cells leave the lymph node and quietly patrol your bloodstream for decades. If a variant of that same disease tries to invade your body 10 years from now, the memory B cells will identify it immediately and neutralize the threat before you ever feel a single symptom. This exact cellular mechanism is why vaccines work. A vaccine introduces a harmless fragment of a pathogen to your body. It bypasses the dangerous infection entirely and forces your immune system straight into the boot camp phase, generating those protective memory cells safely. Because of this long-term cellular memory, humanity has survived historical plagues and modern pandemics. Your body learns from every encounter, continuously updating an internal library of targeted defenses. Back on the macroscopic level, you finally start to feel better. The redness fades, the fever breaks. The severed tissue of your skin knits back together, resealing the physical barrier. Over a single week, billions of individual cells coordinated through complex chemical signals and engaged in close-quarters combat to eliminate a lethal threat. This network of sensors and specialized soldiers operates every second of your life. It is a continuous, invisible effort that ensures your survival against a world of microscopic predators.